Hi, my name is Aiden Simon. I'm in Physics 1401. Today I'm going to demonstrate how fluid density affects buoyancy using a very simple egg experiment. I'll be comparing what happens when I place an egg in regular tap water versus salt water, and I'll explain the results using the concept of density, buoyant force, and Archimedes' principle.
So here I have a cup of plain water and I'm going to gently lower the raw egg into it. The egg sinks straight to the bottom. Right here I'm going to take a few tablespoons of salt and I'm just going to pour it in here, stir it until it's completely dissolved, and the water's going to start to look a little bit cloudier. Here's the underside. And then now I'm going to take an egg and I'm going to put it into the salt water. And you're going to see that it floats. It sits at the surface, which is a very different result from the plain water. So why does this happen? Well, it all comes down to density and buoyant force. Density is a mass per unit volume. Tap water has a density of about 1 gram per cubic centimeter. The raw egg is slightly denser than that, at about 1.03 to 1.1 gram per cubic centimeter. Because the egg is denser than the plain water, it sinks. Now, when we add salt, the salt molecules mix in between the water molecules without adding much volume. This increases the mass of the same volume of fluid, so the salt water's density goes up. Once the salt water is denser than the egg, the situation reverses. This is exactly what Archimedes' principle tells us. A submerged object experiences an upward buoyant force equal to the weight of the fluid it displaces. A denser fluid weighs more for the same displaced volume, so it exerts a bigger buoyant force. When the buoyant force exceeds the egg's weight, the egg floats. That's why we see the egg sink in fresh water but float in salt water, just like people float more easily in the Dead Sea than in a freshwater lake. Thank you.